These are your notes for writing equations from situations, our first lesson in Unit 2. Our learning target is I can write equations from situations. These are some key words you may see in our situations that indicate a specific operation. For add, we have a few examples here. More, earns extra, one-time fees, rise, adds, gives. For subtraction, we have less, owes extra, reduce, falls, subtracts, and takes away. For multiply, we have 3 examples of each, per, and every. For example, every hour I earn $2. And then divide, we have 3 examples again, split evenly, divide, or group. For each of these problems, our first step is going to be to read it to see what's happening in the situation that gets us to our equation. So number 1, Stacy is working at a vet clinic this summer. She gets paid $8.50 for each hour that she works. This past week, her paycheck was $102. Write an equation using x for the number of hours she worked to earn $102. So then we're going to go through and identify our key pieces of information. So those numbers and operations. So we know she's working and she gets paid $8.50 each hour. So we can highlight hour 2. And she made, all of last week, her paycheck was $102. All right. So if I think about the list of words that we just saw, each means to multiply. So I know that I need to multiply. Reading the word problem here, for our equation, we're going to use x for the number of hours. So instead of each hour, it's each x. So it's $8.50 each x. So that means $8.50 times or multiplied by x, our variable. Remember, if there's a number right in front of a variable, that is multiplication. And then we know that she earned a total of $102. And our totals are always here, right? She worked so many hours, getting paid $8.50 each hour, and she earned $102. So that would be our equation. Okay, let's try situation 2. Our first step being to simply read the word situation. Number 2, Mary got a job at Sonic this summer. She earns $5.35 for each hour worked. She also earns an extra $20 for the week because she wears rollerblades while working. Write an equation using h, the number of hours worked, to calculate how Mary earned $116.30 this week. Now we go through and we find our important information, so numbers and keywords. So she earns $5.35 for each hour worked, and she also earns an extra $20. And all of that time worked, she's going to earn $116.30. So now we're going to go through and kind of equate these keywords to operations and numbers. So it says that H is going to represent number of hours. So instead of each hour worked, we're going to think about that as just H. And we know that this word, each, means that we're multiplying. So we have $5.35 times H, so it just goes right next to that number. Then she earns an extra $20. Well, if you look back at our list of keywords, extra or anything added on tells us we're going to add. So this is $5.35 times H, the hours, plus $20 equals that total amount she earned of $116.30. And that's our situation. Okay, example 3, our first step is to read the situation. Daniel plays basketball at his local YMCA. He has 2 payment options. Option A is to buy a membership card for $20 and pay $2 each time he goes to the YMCA to play. Option B is to not get a membership card and pay $4 each time he goes to play. After how many times will the cost of option A be equal to the cost of option B? Okay, now we're gonna go through and find our key pieces of information. And I'm gonna start with the question. So this one's asking me, which is a little different from the others, we're comparing two situations. So after how many times will the cost of option A be equal to option B? That's what we're looking for. So I can kind of write that down here to guide my keyword search. So we're looking for option A to equal option B. All right, well then let's focus on option A first. Let's look into option A and find the keywords for that option. So for option A, Daniel would buy a membership card for $20 and then pay $2 each time he goes to the YMCA to play. So we have $20 just for the card and $2 each time he goes. So we know that this word each means multiplication. So each means that we're multiplying by our variable because we don't know how many times he's going. And we know that it's 2 each time. So that means it's 2 times x. And then if he has an additional payment here of just the card and it's a one-time fee, we're going to add 20. And that is our option A. And we want that to equal option B. So let's look for option B's keywords. For option B, he wouldn't get a membership card and he would just pay $4 each time. Well, if you're paying 4 each time, we know what each means, so it would be 4 times x. And this would be our situation equation. All right, this is our fourth example. This one says the cost to download a song from iTunes is $1.29 per song. Apple Music allows you to stream unlimited songs for a monthly fee of $10. How many downloaded songs D must be purchased for the monthly price of Apple Music to be the same as iTunes? So we've completed our first step. We read the situation. Now we're going to write our comparison statement. So where we find this is in the question here. So it says how many downloaded songs must be purchased for the monthly price of Apple Music to be the same as, which means equal to, iTunes. So we want Apple Music to be the same as iTunes. So I'm going to write that comparison statement for my second step. So we want Apple Music to equal iTunes. Now we move on to step 3 and we look for those key words to create our equations, or to create our equation. So the cost to download a song from iTunes. So we're starting by looking at iTunes side of our equation, and we know that it's $1.29 per song. And we know that the word per means to multiply. And we know that instead of songs, we're going to use this variable D because that's what they told us to use. So for iTunes, it is $1.29 times D, our downloaded songs. And we want that to be equal to the monthly fee of $10. So we just want it to be equal to our monthly fee of $10. It's not $10 per song, so we don't need to attach our variable to it. All right, for question 5, situation 5, our first step's going to be to read. So a 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle burns 0.5 of an inch every hour. The 18-inch candle burns 2 inches every hour. After how many hours will the two candles be the same height? Let H represent the number of hours. So we just finished our first step, which is to read. Now we're going to go through and write our comparison statement. And what we're trying to do, what we're trying to find is after how many hours will the two be the same. So we want our 12-inch candle height to equal the 8-inch candle height. All right, now we're gonna go through and look for keywords to create our equation. So let's start with that 12-inch candle. So the 12-inch candle, which is our first situation, burns a 1/2 inch every hour. So half every hour. We know that every, just like each or per, lets us know its multiplication. And we know that instead of hour, we're going to use the variable h. So we know that we have 0.5 times h. But you need to think about what candles do when they burn, right? We know that our 12-inch candle is starting at a height of 12. And when a candle burns, it's melting. And when candles melt, they get smaller. So our height is actually shrinking a 1/2 inch every hour. For our 18-inch candle, it's going to start at a height of 18, and then it burns 2 inches every hour, again with the multiplication and the h for the hour. And again, we're thinking about a candle here, so it's not adding 2 inches every hour when it's lit. It is subtracting 2 inches every hour. And then we have our equation. Feel free to go back and listen to any example problems or parts of this notes video if you have questions. Now you're going to work on the practice that is found in Schoology.